Hello and welcome to part 2 of, my review on Existential Physics by Sabine Hossenfelder. So, the things we're going to talk about in this one: ontology, reductionism, and I don't know what that last thing is called, but it's during her conversation with David Deutsch. So I guess let's start with ontology, which she's basically talking about, she brings up Lawrence Krauss and, how he famously likes to say of the far distant future that basically we can say whatever we want about what might happen at that time because no one's going to be around to see it. And so Sabine is like, well, I think that it's more like Lawrence Krauss can say whatever he wants to say about that time because he just thinks nobody's going to be around to see him say it, hear him. She said it better. Anyway, but as regards to the predictability of the scientific laws or just the consistency over time of them, I don't know. I mean, yes, the physical laws could disintegrate at any point or they might change or whatever. But I think there is decent grounds for thinking that it's unlikely that, well, I don't know. I guess when you get out to 1 trillion years, that's kind of a far extrapolation, but the universe has been around for, 13 billion years or so, as current estimates go. So, I mean, if you look out, you can see that the same laws of physics governed the universe back then that govern it now. I mean, to some extent. I mean, there's some mysteries surrounding quasars and things like that. But really, I think that projecting forward another 10, 15 billion years, I mean, and even farther than that, if we can say, if we can find the rate of change of the physical laws. It doesn't seem like they've changed significantly. And it's also hard to really extrapolate because the beginning of the universe is so, unusual compared to the rest of it. So, I think it does kind of make sense to say, to look at how the laws have changed in the last 10 billion years and be like, well, is there any change to the physical constants? Is there any change that we can measure, by looking out into space at something 10 billion light years away or something? Is there anything that has changed that we can measure? And then extrapolating that, and I mean, I don't know. That just seems, yeah. So as far as that point goes, I would say, I'm fairly confident the world isn't going to just end. She also brings in, are we a brain in a vat that could have just, occurred randomly through a decrease in entropy that can happen? Not a brain in a vat, but I guess, yeah, a brain in a vacuum. That's an interesting thing, and I think we'll get into that in some of our other videos going forward, because it's just a good topic that I like to think about. So then she gets into her conversation with David Deutsch, and I love it because she prefaces it with, I was excited to talk with David, because he always, makes his points, clear, and, really articulates his points. Which, I mean, I guess, yes, kind of, but I hit that point in the book, and I'm just read it, reread it to understand it. I'm still not totally sure I understand what he's talking about, but she goes to him to ask him about, basically the scientific method, or just, the discovery of theories and things. And she's like, so what is your thoughts on like reductionism? Like, are you a reductionist? And so a reductionist is somebody who's like, we can understand the whole in terms of the sum of its parts. So if I want to understand this area, I could look at the individual rocks, and I could zoom in on the minerals and the things that are in the rocks, and then I could understand where those came from. And basically, yeah, I could explain the whole mountain by just, digging down and understanding the smaller bits of it, and then putting those back together to understand geology and that sort of thing. Well, he's like, I don't know. I could see it both ways. Like, I think it works. It has largely worked well for us to be reductionist, generally in science, but I don't see why it has to be that way. And I mean, I guess personally, I think, sure, I don't really care. Like, whatever works, right? But he brings in an example of a Turing universal computer. And he's like, so there's this idea that a Turing computer should be able to model basically our current laws of physics, and, well, I don't know, the way he made it sound was that it should be able to model whatever physics we could come up with to describe the world, even though he also implied that maybe there were physics that couldn't be modeled with a Turing computer. So I don't know, he didn't really explain that, but anyway. And so he's like, so here we have this like complicated object, and he gestures to his laptop, and he's like, and this is able to basically, the concept of this being a universal computer that can hold within it, that can compute or simulate all the physical laws, that could, in principle, match in like a one-to-one mapping. It's the motion of its particles within it to the entire universe. The motion of the particles within the entire universe. And I don't know. He's like, it's a very complicated object that is able to do this. And so I guess his point is that it's not reductionist, because we're not like reducing things down. We're taking this high level complicated object like a computer and saying something very basic about the world, that like all the laws of physics could be simulated basically on it. And I don't know, I don't really find that, I mean, in principle it could be a good argument, but I don't think we really know enough. And like the way in which we describe a Turing computer is actually not that complicated. I mean, you could look at Turing's original paper, and if you want to find just reduce it down as much as possible, and then you say that can simulate all, like, a huge variety of physics, most of which, basically all of which, don't apply to our universe, only one of which does. And it's like, I don't know, it seems to me that like it is a reduction. Like the idea of a universal computer itself is fairly simple compared to the things that it can do. And so maybe I don't really understand his argument there, but to me, based on that, it doesn't seem like a great argument for an example of something that's not reductionist. And then finally, there's this point he makes at the end of the interview, where I'm still not exactly sure the connection of all that stuff. I think it's basically reductionism. But he's bringing up other examples of things that kind of don't fit into this picture, maybe. So he's got constructor theory, which is his, I guess, the theory that would allow you to not just reduce things in like a reductionist way, but you could understand things from a holist way. And anyway, I need to go back and look that over. I might bring that up in the last part of this review, but he does say, like, if you were to take a person, like, he's talking about, like, the unpredictability of knowledge. He's like, there's certain things that you couldn't predict based on its parts, right? So he thinks that knowledge might be like one of those things where it's like, if you took a person and put them in a jar, just like put them in a, lock them away, and then you were to just like analyze them and be like, now, what are the things that they're going to discover and what are the things that they're going to learn about? And you try to predict the things that they might come to know, you wouldn't be able to do it. He thinks that knowledge itself is like a chaotic sort of system or something that you couldn't predict. And so his point is like, if you had a computer or something that was able to simulate his brain or to simulate his environment and his brain and everything to understand what he might predict, then you would basically just have simulated him. And so the knowledge or whatever that you wanted to predict would have already been in your computer simulation. And so therefore it wouldn't be a prediction, you would have already had it. And I don't think this is a good argument. So like, we could take the example of like pi or something and be like, all right, so we've got an algorithm for generating, you know, pi to however many digits you want to have it, right? But just because you have an algorithm to generate pi doesn't mean that there's nothing to actually converting the algorithm into the numbers, right? Like, it's contained within it. But to say like it's not knowledge to actually convert it into its constituent, or not constituent, but into the resulting digits, I don't know. To me, it doesn't seem to, like, I just don't think that that's great. A great definition of knowledge. So, I don't know. I think I'll think a little bit more about this and maybe I'll come up with a better way to explain it. But I am tired. It's been a morning. I found no gold. Boo. All right.